Good morning, ladies and gentlemen. Today we are starting on the middle of page 4 in your notes, so go ahead and find that. Get with me, please. We are first talking about the areas of trapezoids. So remember, in a trapezoid, the bases have to be the parallel sides. And just to show you where this formula comes from, I want you to realize that two trapezoids make a parallelogram. And notice, if we were looking at this parallelogram, the base would be B1 plus B2. Remember, the formula for area of a parallelogram is base times height. So for this parallelogram, we would do B1 plus B2 times the height. However, since we are just trying to find half the area of that parallelogram, our formula for area of a trapezoid is half times B1 plus B2 times height. You can also rearrange this. It doesn't matter if you put the height first. Or you could even write this as height times B1 plus B2 divided by 2. Or rearrange that numerator. Doesn't matter. Any of those ways, those are all the exact same thing. They all give you the area of a trapezoid. And again, just like yesterday, don't forget height has to be perpendicular to the base. Okay, let's try this practice problem, this example together. It says one of Brianna's trapezoid, it should say isosceles trapezoid shaped totes is shown. Find the amount of material used to make the sides shown. So I know that my equation, if I'm looking for the amount of material, should be the area of a trapezoid formula. Now, this is great. It looks like it should be easy. However, let's check this out. So I know that my bases are the 28 and the 58. It doesn't really matter which one's base 1 and base 2, since the order of addition doesn't matter. But I know that those are the bases since those are the parallel sides. The problem here, though, is that they don't give us the height, sadly. So we have to do a little extra work to figure out the height. So what I'm going to do is I'm going to look at this green triangle here. It's a right triangle. And if I can figure out this bottom side x, which I should be able to do, then I can figure out the height by using Pythagorean theorem. So that's my plan. So what I'm going to do is I'm actually also going to look at this little triangle over here. This right triangle, since this is an isosceles triangle, is congruent to the triangle over on the left. That means that this bottom would also have to be x. So check this out. If this top base is 28 centimeters, wouldn't that mean that from here to here would also be 28 centimeters? Now let's figure out what's left for our x's. If the entire segment, the entire bottom, is 58 centimeters, and this middle piece here is 28 centimeters, let's figure out what's left for x by taking... Are we going to erase? Nope. Okay. Well, looks like that highlighter is going to just stay there. So let's take 58 centimeters minus 28 centimeters to figure out what's left for x. That gives us 30 left over for our x's. So if 30 is left over for two x's, that means 2x equals 30. If we solve that, we will divide by 2 on both sides. So that means each x would be 15. Let's double check. 15 plus 28 plus 15. Sure enough, that adds up to the entire segment, the bottom 58. So now that I know that this bottom piece x is 15, now I can use Pythagorean theorem. So I know a squared plus b squared equals c squared. So 15 squared plus h squared equals 30 squared. 15 squared is 225. 30 squared is 900. Subtract 225 on both sides, that gives you 675. To get h by itself, I need to square root both sides. Now the square root of 675, you can plug that into your calculator to solve, is about 25.981. Make sure you don't round too much here. If you round too much before your final answer, you could be off by a few decimal places. All right, so now we know the height. Now we're ready to substitute in our formula. So the height is 25.981. Our bases we said are 28 and 58. Now to solve, all we have to do is do what we did on that sheet the other day where we were just plugging numbers into expressions. So when we plug this in, we have to add up the 28 and 58 first. So that gives us 28 plus 58 equals 86. Now we can just multiply all this in our calculator. 1/2 you can type in as 0.5 if you'd like on your calculator. And that should give you that the area equals 1,117.173. So my answer plus units, the area, well, they didn't really ask for area specifically. They asked for the amount of fabric. So we'll say the amount of fabric is 1,117.173 centimeters squared. Okay, I have a practice problem for you here. Pause the video and try it on your own first. This one's actually pretty easy. I know you can do this one. Okay, so if your answer plus units was that the glass is 2,983 inches squared, you are correct. You can move on. You don't have to sit here and listen to me explain this. If you got it incorrect, please sit here and listen to me explain this. So the equation, I know that the area is, I can use any of these formulas. I'll just go ahead and do this one. Height times B1 plus B2 divided by 2. Substitute. All right, I need to figure out what's the height, what's the base, and the other base. So I know that 72 and 85 are the bases because those are the sides that are parallel to each other. Next, I know that 38 has to be the height because I see that it's perpendicular to the base. So I'll fill in 38 for height, 72 for one of the bases, 85 for the other base, divided by 2. Now to solve, it's just like what we did the other day. So you have to add inside the parentheses first. So that's 72 plus 85, that's 157, divided by 2. Now we can multiply our numerator together first. That's 5,966 divided by 2, which is where we get the 2,983. And then we just need to add units and explain our answer. All right, go to the next page, please. We're going to talk about rhombi and kites. So remember, these were some of the quadrilaterals that we talked about. Rhombi are parallelograms. Kites are not parallelograms. All right, but either way, it doesn't matter. They have the same formula. It's 1/2 diagonal 1 times diagonal 2. You can also write this as diagonal 1 times diagonal 2 divided by 2. Now notice these little numbers here, this little 1 and 2. This does not mean squared and first power. This is not an exponent. It's just saying diagonal 1, diagonal 2. Do not square this. You will get your answer wrong. It's not a square. It's a subscript. Just to identify which diagonal you're talking about. It really doesn't matter though, because it doesn't matter which diagonal you put where, since the order of multiplication doesn't matter. Let me show you an example. So we'll write out the equation first and substitute. So on this one, it's very easy. I know that one of my diagonals is 8 meters, one of my diagonals is 15 meters. You can choose either one for diagonal 1, diagonal 2. and substitute it in. So I have 8 times 15 divided by 2. That gives me, well, I like to do this. If I see an even number, 8 divided by 2, that's 4. 4 times 15 is 60. So my area is 60 meters squared. All right, for B, this one is a rhombus, but the formula is still the same. 1/2 diagonal 1 times diagonal 2. Now, for this one, it's a little bit different. We have to figure out the lengths of the diagonals first, but it's really not that hard. Remember, in a rhombus, the diagonals are bisected. So since that side half is 10, this half is also 10 feet. It even marks them as congruent for us. So altogether, one of the diagonals is 20 feet. How long do you think the second diagonal is? If you said 24 feet, you are correct. 12 plus 12 gives us 24 feet for the other diagonal. Now we're ready to substitute. So one diagonal is 20, the other is 24. To solve, we can do 1/2 times 20 first, that's 10. 10 times 24 is 240. So the area is 240 feet squared. Go ahead and try these practice problems here. Pause the video, please. Okay, if you got 84 millimeters squared for the first answer, you are correct. If you got the area is 72 inches squared. Whoop, what's happening? Why can't I write? Oh, I do not want a keyboard. There we go. Inches squared, you are correct on that one. So if you got those, you can go ahead and skip down to the bottom. If not, pay attention. I'll show you how to do it. For the first one, it's similar to the second problem that we just did together. We have to find the length of the diagonals first. So the first diagonal, we have 6 plus 6. So the first diagonal is 12. The second diagonal is 7 plus 7. So that's 14. So to substitute these in, we have 12 times 14 divided by 2. To solve, you multiply 12 times 14, then divide by 2. That should give you 84. And then you need to add your units onto the end. For the second one, this one's a kite. They already gave us the length of the diagonals. Doesn't matter which one's diagonal 1, which one's diagonal 2. You can just go ahead and plug them in. So you have 16 and 9. You can go ahead and multiply 1/2 times 16 is 8. 8 times 9, I know, is 72. That's where I get my answer. Add on the units, and you're done. Okay, go to the next page. We are skipping this finding measures, and we're moving on to these practice problems. So this first one, we're finding x. So set it up. We know the equation for area of a kite is 1/2 diagonal 1 times diagonal 2. Substitute. I know the area is 92 inches since it told me here. Times 1/2. One of my diagonals is 22 inches. My other one is x. Now to solve this, what I would do first is multiply 1/2 times 22. That's the same thing as 22 divided by 2. 22 divided by 2 is 11. 11 times x. To solve that for x, I need to divide both sides by 11. So that gives me 92 divided by 11 for x. That doesn't reduce as a fraction, but I can go ahead and write this out as an approximate answer. X is approximately equal to 8.364 inches. All right, this next one is probably the hardest problem we're going to do today. So pay attention, please. I know it's the end of the notes. You might be getting tired, but this one is worth paying attention to. So for this blue triangle, we need to figure out this length so that we can know the length of the diagonal. Remember, the blue and pink triangles are the same. In this kite, one of the diagonals is always bisected, I know that that's this diagonal, since the blue and pink triangles are equivalent. They have to be congruent. So I know one of my diagonals is going to be x plus x. My other diagonal, let's call this y. My other diagonal is going to be 6 plus y. So I have to figure out x and I have to figure out y before I can even figure out my diagonals. In order to figure out x, let's look at my blue triangle here. Alright, it's a right triangle because remember, diagonals in a kite are perpendicular. So let's do Pythagorean theorem. 6 squared plus x squared equals 10 squared. So that gives us 36 plus x squared equals 100. X squared equals 64. Therefore, x has to be equal to the square root of 64, which is 8. So I know one of my diagonals is 8 plus 8. My first diagonal is 16. All right, now we still need to figure out y. So now that I know this is 8, let's look at my yellow triangle. I have another right triangle. This time, I can do Pythagorean theorem again. 8 squared plus y squared equals 17 squared. Let's see, 8 squared is 64. 17 squared is 289. Subtract 64 on both sides. You should get 225 is equal to y squared. To get y by itself, you need to square root both sides. The square root of 225 is equal to 15. Alright, so y is 15. That means that my second diagonal is 6 plus 15. So my other diagonal is 21. Now that I have my diagonals, I'm ready to substitute into my equation. So I have area equals 1/2 times 16 times 21. You can just plug this into your calculator by taking 0.5 times 16 times 21. When you plug that in, you should get 168. So for my answer plus units, the area is 168 inches squared. There you go. All right, so for your homework tonight, you have page 793. You are doing numbers 8, 16, and 20 for goal 3. However, for goal 4, you are just doing number 12. You can skip 26, and you do not have to do the one for the honors class. And then you have the reflection question number 34 in the book. Here are your problems for tonight. If you have questions, please post them on our discussion board. Hope you have a great rest of your day. Bye, guys.